Hello. We come to the code of right shift on the elements of an array. Right shift means all the elements will switch over to its next place. Now the last element will unfortunately not be possible to be kept in this time. This time we are allowing the last element to get lost because all the elements are shifting to the right. If it is shifting to the rightmost is probably falling off kind of. But how is the code working, and later we will learn how to rescue it also. So don't worry, we are not losing it out in the final thing. Now you see, what is the meaning of right shift? Right shift means the current element will shift one to the right. That means to the next. That means I can say that the current element is going to the right, or I can also say that each element is getting replaced by what is in its left. See the example for easy understanding. So what was in place of cell number 3 is now in cell number 3. What has come is what was in cell number 2. This is why I can say 745 got a right shift, 602 got a right shift, 551 got a right shift. All this shifted to the right. Okay. Now, what is the main difference between left shift and right shift? It is, if you do the work from the left side, that means if you in the very beginning, if you shift the first element to the right, then what happens is the element at this place is lost. So 852 gets overwritten by 927, which has happened in the first two cells in this time. But if I do the work from the left side, that means from 0 to 7, not 8, 7, then 927 will overwrite 852 and 852 will be nowhere. Then that will overwrite 745 and then 745 also will be nowhere. In this way, what will happen if I do the work from left to right, then the entire array will get wiped away. I will show that to you in the next example. Okay. So what we do in right shift is we take the array's traversal from right side to left side by allowing the last one for now to get overwritten. The first movement takes place when I move 256 to the next. Then I come back and I move 382 to the right. Then I come back and move 492 to the next. In this way, the accommodation is done from right side to left side. Okay. I have got one more variation to show you here. Just observe. Do you see that the source code here has changed? Do you see that the loop range has also changed? Note that P has this time been modified to start from n-2. That means last time it was starting from this position, last, and it was bringing in one by one. But this time it is starting from the second last and it is sending one by one. You see, P plus 1 is given what is in P. So P is here and it is giving that. So this both these codes do the same work and you are most free to choose which one you will use. Be very careful with the limits and redo it once all by yourself. You will see the clear difference between left shift and right shift. And now let me show you how to save and rescue this 149 from getting lost. To save 149 from getting lost, it is logical to bring it to the front. Just observe. What do you think has happened? I did something that you should notice now. Do you think 149 is getting lost after the right shift? Where is 149 in the output? See, 149 has been brought from the end to the front. What we did was, before the shifting took place, we took 149 in TMP, a temporary variable, and after the full shifting was done, we brought TMP to the front. Hence, this circular effect and this kind of shifting is called circular shift. So, this is a code of right circular shift. You may do any one of the loop choice. Okay.